This is Algebra 2, Unit 13, Lesson 2 on population parameters. Now, when we conduct a study, the complete set of all subjects that share a common characteristic that is being studied is known as the population. Basically, what group are we studying is the population. And all populations, because they can be made up of anything, have natural or inter-individual variability. Most of the time, the entire population is not measured, but a sample is taken to infer characteristics of a population. You can't survey everybody in the world when you're trying to do a study, so you have to take a sample. Still, all populations in theory have parameters that describe the population, such as the mean, the standard deviation, and the interquartile range. So we talked about those back in Algebra 1, but it's been a while. So let's see if we can do some review on how those look. All right, let's look at exercise 1. 18 students in Mr. Weiler's advanced calculus class took a quiz with the following results in ascending order. So these are the scores of the quiz. Use your calculator to determine the mean, median, and the quartiles of this data set and construct a box and whisker plot. Okay, so remember how we do this with the calculators. Let me grab my calculator. All right, so all you have to do is press Stat, Edit, and then you just enter your data in L1. We've done this 100 times. I've already put the data in there. Okay, so remember to figure out once you've got the data in there, you press Stat, Calc, number 1 var stats, and then we make sure where your data is. This is in list 1, and just go down to calculate. All right, so first of all, which one of these values is the mean? Well, the mean is the x bar. All right, so if I go back here, the mean is going to be 83.7. That's approximately what the mean is. Okay, now we need the median. The median is the middle number. If we scroll down here on the bottom, remember when you do a box plot, you need a 5-number summary. The median is part of the 5-number summary. It's right there. The median is 84.5. And we also need to know the min, which is 56. We can do that from here. And the max, which is 100. And then the 2 quartiles. Remember, quartiles means dividing the data into 4 groups. Quartile 1 and quartile 3 are the 2 quartiles. Quartile 1 is 75, quartile 3 is 93. So these 5 numbers right here is what a box plot is made up of. So Q1 is 75 and Q3 is 93. So let me write them down here. Q1 is 75 and Q3 is 93. Okay, so if I want to construct a box and whisker plot, I need these 5 numbers right here. Okay, so if I want to do my box plot, first of all, I'm going to need some kind of scale. So I'm going to start, say, let's see, my numbers start at 55 and go by 5. So I can do whatever I want. 55, 60, 65, 70, 75, whoops, 80, 85, 90, 95, 100. Okay, so with these 5 data points, remember the whiskers are the max and the min, so that would be 56 would be here, and the max is 100. And then the other 3 values are quartile 1, which is 75, which is right here. The median is 84.5, which would be very close to 85 right there, and quartile 3 is 93, falls right there. All right, remember you box in the 3 middle ones. The median is always the line inside the box, and then the whiskers are the max and the min. Okay, so going from there, that means this is the min, quartile 1, median, quartile 3, and the maximum. All right, now if we're looking at our data right here, that means that our median is going to be right here. That divides into 2. That's the median, which was 84.5. The minimum was 56, which was down here, and the maximum was 100. Quartile 1 is 75, so that means if I take this half of the data and split it in half, that would be right here. This would be quartile 1. And then quartile 3 would be this half of the data split in half, and that was at 93. That would be right here. That would be quartile 3. So you can see 1, 2, 3, 4 groups when you have the box and whisker plot. All right, so what we want to look at now is what the interquartile range is. All right, interquartile range is the range between Q3 and Q1. So IQR, interquartile range, is Q3 minus Q1. Now remember, Q3 is up here. What percent of the data is at Q3? Well, that would be 75% of the data is at Q3. Okay? And then 75% of the data falls below Q3, and quartile 1 is 25% of the data. So if I do the interquartile range, Q3 minus Q1, it's 93 minus 75, which is 18. So that means, since Q3 and Q1 are the percentages, 75 minus 25% is 50%. So 50% of the data, theoretically, falls between these points. Falls between these points, theoretically. All right, now our interquartile range came out to be 18. So if we are looking for the interquartile range here between Q1 and Q3, if I look at these values, I have 1, 2, 3, 4, 5, 6, 7, 8 values. Out of those 18 is actually 44%. So that's pretty close to 50%, not exactly. So theoretically, the IQR should be about 50% of the data. This actually came out to be about 44% of the data falls between those 2 points. So that's interquartile range. Okay, population standard deviation. What is the population standard deviation for this data set to the nearest tenth? All right, that also comes from our var stats here. Population is this circly thing. It's the Greek letter sigma. It's the lowercase sigma. So our population standard deviation is 11.7. So population standard deviation is 11.7. So how do you interpret the standard deviation? All right, standard deviation is a measure of spread. It means, on average, any given data point, that is given on here, lies 11.7 point units away from the mean, which in this case is mean x bar, which is in this case with 83.7. So that means if I were to pick any of the data points, I'm looking at its spread. So each of those points is on average 11 points away from that. So what does that mean? Our data is more spread out, less spread out. The higher the standard deviation, the more spread out it is. The lower the standard deviation, the more close together it is. So standard deviation is equivalent to how the data is spread out. Is spread out from the mean. All right, so it's how the data is spread out. Okay, so what percent of the scores were within 1 standard deviation of the mean and within 2 standard deviation of the mean? All right, so basically what we want to look at is how far away from the mean 1 standard deviation is on either side. All right, so if I take the mean minus 1 standard deviation, I end up with 83.7 minus 11.7. Which is 72. Okay, and if I do the mean plus 1 standard deviation, I get 83.7 plus 11.7, which is 93.4. All right, so if I go back to my data set right here, the mean minus 1 standard deviation is between 72 and 93.4. All right, so 72 is not included on my data set. Well, it is included. No, it isn't because it's between. All right, so that would be the mean minus a standard deviation would be here, and then 93.4 would be fall right here. That's a mean plus the standard deviation. So how many points fall between there? It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I count that? Yeah. Okay, it would be 10 out of 18, which would be about, which is approximately 0.56, which is 56% of the data falls between 1 standard deviation and the mean. So more than half of them fall between those two values. All right, now within 2 standard deviations, if I do the mean minus 2 standard deviations and the mean plus 2 standard deviations. So the mean was 83.7 plus, or minus, sorry, minus 2 times 11.7. That works out to be 60.3. And the mean 83.7 plus 2 times 11.7, that ends up at 107.1. So between those two values, how many fall between 2 standard deviations? All right, so 60.3 is right here. That's the mean minus 2 standard deviations. And then 107 would be up here. That's the mean plus 2 standard deviations. So almost all of them, 17 out of 18 scores fall in that area. So that's actually going to be 0.94, which is 94%, approximately 94%. So you want to look at where it falls compared to the mean. The standard deviation tells you about the spread. All right, now there's different ways to group data as well. We can also do data which in a frequency chart, like this right here. We can still do the population parameters using our calculator. We just have to be careful how we enter them. So a small company has salaries for their 50 employees is given this arrow below. So instead of having to type in 50 different data points, what you're doing is a frequency table. So there's 5 25,000s, 32,000, 21 of those, 45,000, 14, and so on and so forth. Okay, so to enter these in your calculator, you do the same thing. Stat, edit. Now, if I want to clear this out quickly, just arrow up to L1, press enter, press clear, and then enter again, and that clears it out. So enter your values in L1, 25,000, 32,000, 45,000, 58,000, 75,000, whoops, and then 120,000. So if I enter all of those values on L1, then I put the frequency in L2. So it would be 5, 21, 21, 14, 7, 2, 1. All right, notice put enter after each one. Now, when I do my calculations for this, the mean and the standard deviation, stat, calc, var stats number 1, but I want L1 for my list, but a frequency list L2. So to get L2, remember you do second and then the 2 and press and go down to calculate. And that gives you your var stats. So your mean will be 42,060 and your median will be 32,000. So if I write that down, the mean is $42,060 and the median is, or excuse me, standard deviation, I'm sorry, I looked at the wrong one. The standard deviation is $16,567.93. $16,567.93. So what is the median of this data set? The median of this data set was 32,000. Sorry about that. The median is 32,000. Now, if this data is grouped, should the mean and the median be pretty close? Well, this is 42 and this is 32. That's quite a difference. So why is the median considerably lower because of the mean in the data set? Well, that's because of these salaries right here. All right, those are fairly high salaries, aren't they? And are there a lot of them? No, there's not a lot of high salaries. The higher salaries throw off the mean. The higher salaries affect the mean. So they are called what's called outliers. So they would be called outliers. Okay, so does more or less than 50% of the data fall within 1 standard deviation of the mean? Show the analysis leads to your answer. All right, so let's save this for the next class and we'll finish up the rest of the notes then as well.